Welcome to a new edition of the Heat Treat podcast. Today we're talking nitrogen generation. And today we have a great guest all the way from the Carolinas, Paul Cairney. Is that how you pronounce your last name, Cairney?
Cairney, perfect.
Glad to have you here, Paul. Nitrogen generation has been like a trend of topic in the last 5 years. People do not want to pay for a storage tank on their facilities. And I believe this podcast is going to be very educational to the users, the heat treaters, that they have nitrogen needs, right? For safety, for purging, and they haven't heard of nitrogen generation technology. So how's it going, Paul?
I'm doing great.
So tell us a little bit about yourselves, the company you work for. What do you do? How do you started in this industry? Because I understand that the company that you work for, which is South Systems, is not only meant for heat treat, but has other applications as laser cutting, just beside heat treat. So if you could give us a little background about yourself, the company that you work for, and how that intersection was on the heat treat industry.
Yeah, excellent. Briefly about myself, I'm obviously not from the Carolinas. I'm from Scotland and moved to the US in 1989 to attend university. And I worked with the state and actually retired.
You actually do look Scottish. You know, you have the red hair, right?
My wife says I look like Shrek most of the time, who's Scottish. So retired and was looking for something else to do and fell into this company, South Systems. And as you stated, Carlos, South Systems are involved in nitrogen generation in a variety of markets. We actually started in the beverage market. Nitrogen's used to pair with the CO2 when they're pouring different beers to temper the flow. In fire protection, nitrogen's used as a fire suppression. So those were two of the markets we started in, and in the last 7 years, we've expanded to heat treat, laser cutting. We have a big military market, food, lab, chem. There's in us thermal processing, cold spray, thermal spray. Nitrogen's used in hundreds of different applications.
It is. Nitrogen is it's a application with a wide variety of industries. I will believe that was there ever a shortage of nitrogen that you recall, like the beginning of the year with this COVID pandemic, there was a shortage of oxygen on the industrial market. Everybody wanted to use oxygen for the respirators.
Right.
Has there ever been like a nitrogen outrage?
Good question. Yeah, we deal with some oxygen generation also through a third party. So we saw an increase in requests. The shortage of nitrogen, not as much. It's prevalent in the atmosphere. It's the most abundant gas in the atmosphere. The only shortages come from supply line issues of truck deliveries, can't get drivers, stuff like that. But there was not a shortage.
Okay, now let's get a little bit into technicalities, right? So we talked about the nitrogen is one of the most abundant gases in the atmosphere, right? And the application on the heat treat might vary. Somebody might use it for quenching, some other might use it for purging, some other might use it for another process. But how did you saw as a company that there was a market on heat treat? And having said that, you mentioned 7 years ago was when Southex started to enter the heat treat market. And I was a part of that. I saw how Southex started to market, right? And I believe you have done a fantastic job because now you're like a player in the market. So why don't you tell us, where did you saw that niche? What were companies were doing that you saw that there was an opportunity for a supplier like yourself?
Good question. The one of the first bigger projects that kickstarted it was actually with Nissan down in Mexico. and they had issues with the cost of the nitrogen they were getting supplied, the reliability of deliveries, and that kickstarted a big project. And Dr. Dan Herring, who I think everybody in heat treat knows, Dan,
the heat treat doctor,
the heat treat doctor, yeah. He was involved in consulting at the early stages with South-Tech, and I actually spoke to Dan 2 days ago. He still helps us with different projects. And that really kick-started. We don't know metallurgy. We don't know everything that he knows. So we lent on him to teach us about the different applications within the market. And then, as with any new technology, it takes time to get traction. It takes time for customers to trust that they have the liquid bulk.
The industry has to digest you.
Yep. It's like 35 years ago, the microwave was this newfangled thing, and now everyone's got a microwave. You know, it was new back then, and I think nitrogen generation is still relatively new in heat treatment.
And how does it works? I mean, we know that the big corporations that put a tank on your backyard, they charge you a fee, right? And trucks come and buy and they just fill it up, right? And there was this new model, like endothermic gas generator, say, you know, well, you don't need that bottle. We can actually give you a machine that will make a process, and nitrogen is going to be the final product. Can you explain us a little bit about the mechanics or the transformation or the chemistry that happens?
Okay, great question. And I may go off topic, but keep me on task here. Because nitrogen is the most abundant gas in the atmosphere, it makes up 78% of what we breathe anyway. We take compressed air. So an air compressor is the foundation of the separation process. So let's say we have an air compressor at 115 PSI, and it's feeding 100 cubic feet per minute of nitrogen, of air. The compressed air enters the generator, and there's two beds behind the generator. We'll call it sieve bed A and sieve bed B. And as the compressed air enters the first bed, the oxygen molecules are smaller than nitrogen molecules. And inside each of those sieve beds is a sieve material. We refer to it as carbon molecular sieve. If you magnified it 1,000 times, it would look like Swiss cheese. There's small holes, and the CMS material selectively adsorbs oxygen molecules. And the key word is adsorb, ADSORB. It doesn't absorb, it doesn't change the medium itself. So the oxygen molecules have got a higher kinetic energy. They're smaller than nitrogen. So the CMS material adsorbs them for a minute, 45 seconds, then flows through to process. And then what happens, Carlos, is the bed swings as one's pressurizing, the other's depressurizing, and so on and so forth. And that's why it's called pressure swing adsorption. It's a continually efficient process of making nitrogen from compressed air.
So you're basically sucking air, and you have materials like kind of a net, right? And then you're playing with pressures. That's correct. That's in a nutshell.
That's pretty much it. At the inlet to the generator, we've got 3 filters. So the filtration is very important. We have a particulate, a coalescing, and an absorber that take care of oil, moisture, and any particulate. So we're actually producing a cleaner, drier gas than the gas company are, because we dry the air, and then the nitrogen generator itself dries the gas even more. So the dew point of the final gas is drier than most people are probably used to.
And now that we're having a machine generating the gas instead of having the supplier delivering the gas to a bottle, with the machine now we have to take other actions like maintenance, constant checkups. I don't know if there's a calibration. changing of filters, switches. What are the items that come with the machine or the responsibilities that come with the machine when you want to balance tank against versus generator?
Okay, so the air compressor is again the foundation. So if the customer has already got shop air dedicated to other applications or processes, then we would dedicate an air compressor that has its own preventative maintenance schedule that we have to follow to make sure there's the valves, the filters, filtration is kept up to date. So that's one cost on the front end. The other consumables, if that's your question, the filters are changed every 6 months at the inlet to the generator. After that, everything else is self-contained. There's really, it's very low maintenance. Think about a liquid bulk tank is evaporating a liquid to a gas, and there's different pressures involved. There's more danger involved with liquid nitrogen. We're basically taking air and just making another gas, nitrogen. So there's not a lot of maintenance involved. The air compressor is really the only maintenance issue we have to deal with. After 5 years, we recommend a recalibration of the oxygen analyzer, especially in the higher purity applications. We'd probably actually calibrate that maybe every year to make sure that it's still reading. And then there's some valve replacement after 5 years, but again, nothing major.
Now, having said this, there's the generator itself there, but when you generate the nitrogen, do you flow it directly to the application, or do you flow it to a storage tank that will have the gas in standby when needed?
Good question. The majority of our projects in heat treat are sized on demand, meaning if let's say a customer's got 4 furnaces and they require 1,000 cubic feet an hour of nitrogen. Again, just for an example, whether it's a process flow or a soak or a purge, whatever, if the maximum needed is 1,000, then we would design a generator, Carlos, that would provide 24 hours a day, 7 days a week, 4,000 cubic feet an hour of nitrogen. So the tank after the generator is really a buffer tank. It's not a storage tank.
It's like a buffer tank. Okay.
It's like a buffer tank.
So it is continuously filling and
correct.
itself.
Correct. And there's a cut in, cut out pressure in that buffer tank that will click to the generator to make more nitrogen as needed. Anytime there's a pressure drop downstream, that pressure drop will signal the PLC to the air compressor to make more nitrogen.
So you basically have this bottle pressurized, and whenever you start using some of the pressure, we get the signal. We got to generate more nitrogen until
correct.
The pressure, the desired pressure. Okay.
Correct.
Okay.
Now on the flip side, there's 3 or 4 different options where if the customer has like a vacuum quench they have to satisfy.
Right. That's like a peak.
Yeah, that's like an intermittent use that may only happen for 2 hours every 24. Mm-hmm. So in that scenario, we would have a high pressure booster and we would boost to cylinders and actually store the nitrogen for that quench. And that's an option. We actually have a cold spray application. I know it's not heat treat per se, but that's what we're doing in that project where we boost the nitrogen to 4,000 PSI for storage, and the customer can regulate that down to whatever pressure they need.
And I believe it's a great topic because there's some processes that uses a constant flow, and there are processes that uses a peak, right? So you say you had a buffer tank when the pressure is kind of constant, but
correct.
We have to add boosters when there's going to be a peak on demand of the gas on a quenching process or on a purging of a process or a purging process of a furnace. We need to add some boosters.
Yeah. If we did an x-axis and y-axis configuration of the perfect project for nitrogen generation, it would be a process with continuous flow over time.
Continuous flow over time.
Yeah. So one of our most recent projects is an annealing application. they're annealing precious metals, and the nitrogen flows 3,500 cubic feet an hour for 12 hours, 14 hours. So that's really expensive if they're paying for that per 100 cubic feet of nitrogen. So that's why it's a good fit for long continuous flow processes.
Now, I got a question that I have always wanted to ask, like an expert on something like yourself, and it's about purity, right? Because whenever we have, of course, I'm a heat treater. I don't know if you knew.
Oh yeah, I know.
There's a couple of customers that come like, do you have nitrogen capabilities? We do for purging, for something like this, inert atmosphere. Well, like we do, and they always ask, what's the purity? But there's some customers that they don't care. Why is the purity of nitrogen important on heat treatment? I totally understand for if we're talking on the medical industry. I totally get it. You want to have the nitrogen in its purest form. But why do they care so much? Or what are the key components to understand when talking purity?
Okay. So let's rewind to what we mean by the purity of the nitrogen. Typically, in heat treat conversations, we talk about either the percentage purity of the nitrogen or the parts per million of oxygen. So if we say the nitrogen is 5 nines pure, okay, it's 99.999. So 5 nines is less than 10 ppm parts per million of oxygen. And then all the way down to 4 nines, 3 nines, 99, and so on and so forth. There's a couple of reasons. Number one, the gas company, they got to write the specs on so many applications 25, 30 years ago.
Okay.
So if they've been delivering the specs at 498 purity, then the customer expects, well, that's what I need. Mm-hmm. So that's an obstacle that we face. Luckily we have got smart guys like, Jim Senney and Jim Wilbur and Dan Herring that can tell the end user, you don't need the high purity. The nitrogen.
So the answer will be because the spec say so.
Kind of. Yeah.
And now, we find a lot of that on heat treat. I mean, we when we heat treat stuff, sometimes and we have several podcasts about this, like, what do you need this case then? What do you need this type of quench media? And they go like, well, because the specs say so. And there's guys that know the stuff like Jim Senney and the Wilburts and many, and Dan Herring, of course. And they go like, well, you can do this on a bunch of ways and get the same results. But if the specs say so, the customer wants you to follow the spec. Mm-hmm. So.
And the other obstacle is there's sometimes a confusion between the cleanliness of the gas and the purity of the gas. In other words, if the customer might think, well, if it's not pure, it's not clean. Does that make sense?
Totally. So I will think that. I mean, the purer it is, the cleaner it is. So that's not correlated?
Well, the purity refers to the parts per million of oxygen. So you could have industrial grade standard gas that's 498, less than 25 ppm, but it's full of particulate, or it's full of there's a low dew point and it's got moisture in it. So the cleanliness of the gas can be just as important as the purity of the gas. Free of particulate, free of oil, free of moisture.
Got it. And we deal with a lot of endo generators. I don't know if you're familiar with those. And of course, we always measure the dew point. It's like the big thing. And depending on the altitude, if the day it's a little humid than other days, we see significantly changes on the dew point. Is it the same with nitrogen generation?
Yeah. So the good thing is we do have the filters at the inlet of the generator for the air, and you'll find in a high humid atmosphere the the absorber filter will need to be changed maybe quicker because it has to absorb the moisture. We also put an air dryer, a refrigerant air dryer or a desiccant air dryer before the generator, so that we're providing the generator with clean, dry air, and those filters catch any moisture issues on the front end.
And the moisture will have to be cleaned with the filter every now and then, as we spoke with the maintenance. So how do we, on applications on heat treat, you just gave the example when having 4 furnaces or 8 furnaces, and then you size the generator that you need. But sometimes on this kind of situations, production is intermittent. You will need to expand for more capacity, let's say to add 2 more furnaces, or the business might not be so good and you have to reduce your production to 2 furnaces. Will you still use the same energy? It doesn't matter if the nitrogen will be stored on the baffle tank for so much time? Is there like a limit? What can you tell us about expansion and reduction of usage?
Okay. On the front end, expansion is more challenging because if you're the customer, Carlos, and you say, right now, I got 4 furnaces, 1,000 cubic feet, and I might add 2 in the next 2 years, then we would size it on the front end to accommodate that flow. It's cheaper to do it that way. So we have that in-depth conversation with the customer to say, do you plan to expand or add to these lines?
Which sometimes is the case when you buy capital equipment, right? You go like, well, my production is not going to peak in the first 2 or 4 years,
right?
But we need to be ready in order to meet this demand in the next 5 to 10, right?
Right.
But
so if we size it at X cubic feet per hour, it's going to be challenging to upsize that within the same model.
Mm-hmm.
So we need to know on the front end,
or selling a new one every other year.
Right.
That's
yeah, and one of the projects we actually did with
you got Jim City, right? He's a great salesman, so
I'll let
sell him a new one, right?
Yeah, I'll let Jim do that.
Right.
On the other side of it, it's really quite simple. The nitrogen generation works on pressure drops downstream. So if there's only 2 furnaces sucking the nitrogen, not 4, then that's all the generator is going to make.
Okay.
The issue is the air compressor will cycle because there's a constant oxygen analyzer coming from the storage tank back to the PLC. So the air compressor is still going to be making nitrogen, but small amounts because it's pulling back. So or sometimes they might shut down for 2 weeks and it's not making, then they have to run the air compressor a few times through the system before they start producing nitrogen the next time.
And what's the longest the nitrogen can be on the baffle tank without flowing?
Good question. Maybe 4 shifts, 2 days.
2 days. Otherwise, it will just make sense to open the valve and release everything and just generate.
And that's what we do. It's actually one of our kind of trademark. It's called Purity Protect, where if we know the customer needs a certain purity, the O2 analyzer is constantly reading that buffer tank, and if it's below the minimum ppm, then it flushes that tank 2 or 3 cycles to get back up to purity before it goes to process.
And now let's switch a little the topic for applications. What are the most applications that you're seeing on your RFQs for nitrogen on heat treat? We have mentioned vacuum, we have mentioned purging. There might be another process involved. You just mentioned annealing, which is protective atmosphere. What you have seen on the market, and is every nitrogen generation capable of actually serving that need? Does a nitrogen generation that is meant for vacuum quenching, or gas quenching, or purging of an atmosphere, or just protecting an atmosphere from time to time? What are the applications you see the most, and which is the challenge with each individual one?
Okay, so in general, now there are exceptions. In general, a nitrogen generator is a better fit for an atmosphere furnace, whether it's like a batch or continuous. The ability to serve a vacuum with the high volume needed in a short amount of time makes it more challenging. So protective atmosphere, definite and easy fit for nitrogen. It just flows as a cover gas, if you like.
So that's bread and butter for nitrogen generation, atmosphere.
It's bread. That's probably 85% of our successful projects are in atmosphere.
When you mention atmosphere, do you mean nitrogen atmosphere or a mix of systems? Because there's also nitrogen methanol generation.
Yep.
There can be I don't know if FNC will be like the ferritic nitrocarburizing.
Yep.
when you just
ammonia. You've named off some of our successful projects. So let me just clarify when I say the atmosphere, meaning if the gas is used as a protector, is protecting, or it could be used to interact chemically with the metal.
Right.
So yeah, both like an active and a passive application. So
how do you say it? I love it when you say when you use passive gas, you mentioned that, or when we do want to have a chemical interaction with the part. So that's protective and chemical interaction. So is that what you're referring to?
Yes.
Okay.
If there's two simple uses of nitrogen, one is as a protector, like a passive, it's not interacting with the actual metal for any metallurgical reason. And then the other side is whether it's a nitrogen methanol atmosphere or a nitrogen hydrogen blend. Those are the ones. The first one is probably 65% of our projects.
Protective.
Yes.
Okay.
And then metallurgically interactive, 35-40%.
And of course, when we say metallurgical interacting, we're talking about gas quench as well.
Yes.
Okay. And having reviewed that, what are the key things to consider, or the mistakes that you see with the users or with your customers that can be easily avoided, and because of lack of education or because of the technology is just so new, you wish they knew? What would you like to share with them that very easy tweaks that can make their life much more easier if they these tweaks?
So there's three main criteria, Carlos, that we size a generator on. It's the flow rate, the maximum flow rate the customer needs, what pressure they need, and then the purity. The flow is easy, the pressure is easy, and the conversation.
I'm going to stop you for a second here. I get it, but can you just explain for the audience what's the difference between flow and pressure? Because this is a question some people I know, they don't get. I mean, flow is very different than pressure, and they have to take that into consideration. So can you just give us the 101 on flow and pressure?
Yeah. So if the gas is flowing at 100 cubic feet per hour, the pressure could be 80 psi G. If the gas is flowing at 100 cubic feet an hour at 100 psi G, then more of it's flowing a quicker time. So the higher the pressure, the more velocity of the gas. That's a Scottish guy's way of explaining something pretty simple. We deal with volume and flow as well. A lot of heat treat people talk in terms of volume.
Yes.
I don't know if you know Mark Hemseth with Seco Warwick.
I do.
He was chatting with me a while back, and we were trying to understand for the integral IQ, the super IQ, and nitrogen's used in that. And we were trying to decipher if you need 100 cubic feet in 15 minutes, that's 400 cubic feet an hour. Does that make sense? Or if you need 1,000 cubic feet in 30 minutes, then that's 2,000 cubic feet per hour.
Correct.
So it's like the difference between distance and time, or speed and distance, right? Speed's got just speed. You're going to 80 miles an hour, but distance is how quickly do you cover that speed in a certain amount of time. So flow rate and volume and cubic feet are sometimes hard for us to ask the end user the right questions to get them to figure it out. The other thing in terms of the end user is nitrogen generation used to be based on membrane separation. They used to use membranes to separate the oxygen and the nitrogen. And that's an obstacle we have to overcome. We're not using a membrane. We're using the carbon molecular sieve material, which is, you can get higher purities of nitrogen.
And with the higher purities, now using this, I like to call it a net. You know, I refer it as a net because I was familiar with the membrane technology, right? Mm-hmm. But that technology has a little more time in here. Now, when using this type of applications, I'm playing with the pressures inside the machine. If we have a bad pump and we're not playing correctly with the pressures, is the nitrogen going to be less pure or less clean?
Okay. So again, the air pressure coming in is from the compressor, okay?
Right, you're sucking air in.
Yep. So if there's any issues with pressure, the PLC will alarm, and the PLC can be connected to their cell phones through the download of the Unitronics app. So if there's any drop in pressure, then yeah, we would lose purity, but there would be an alarm that would go off. That typically doesn't happen in the heat treat application. We don't really have that many drops of purity.
And this is what I'm asking, because on heat treat environments, we have soot, we have carbon, we have fumes, we have dust, and the generator is actually sucking air from the ambience, and it's not going to be like the best ambience ever. And if we're talking about annealing, we could be on a forge or in a foundry, right? And mm-hmm. those are also very dirty. And when we're sucking air from the air to a machine, the filter gets pretty damaged or even stuck. So will that be an issue, having a generator on a heat treated environment in order to get purity on the final product?
The purity, no, but the cleanliness possibly. So right. we need clean air in to get clean nitrogen out. Okay.
Okay.
So if we know we've got a dusty atmosphere with metal powder and soot and everything else,
that is a standard. That's a standard environment for heat treat.
Yep. So we recommend the air compressor is located in a well ventilated area. We also would recommend pre-filtration. So filtration prior to the inlet to the air compressor, and then maybe recommend a higher volume of filter changes at the inlet to the generator. So, filtration along the way to protect that gas would be the solution.
You sound like a real estate guy, like filtration, right? So that's like the key of purity and cleanness of nitrogen. I just got that. And a follow-up question into that: how far can we go from the baffle tank or generator to the furnace itself? What's the recommended length?
It can be anywhere, really.
You can pump it, right? But do we lose something?
No, we won't lose pressure of a significant amount unless, some of these heat treat facilities, as are 500-600 yards from the nitrogen supply to where the furnaces might be. Mm-hmm. So we would take that into account. With our engineers would design maybe a higher pressure if they think we'll have some pressure drops. If the piping's got multiple turns, elbows, up, down, around, then we may have some issues with pressure drop, but not a significant amount.
When you mentioned that there's a lot of engineering involved, is every system custom, or are there standard products according to the amount of nitrogen that you need? Is there some standard question. Products, or everything is tailor-made?
Everything is engineered to orders, customized.
Everything is tailor-made. Okay.
Everything.
Okay, good. So there's a lot of interaction with engineering. And
Yeah.
and I gotta ask you, whenever you get, let's say you got an RFQ, right? And they go like, well, I would like to have a nitrogen generator, please. And they go like, well, how much? And they go like, medium size, not so big, no so little, right? I got 2 furnaces. How do you work with the people that do not have the technical specifications of their needs?
Okay.
That happens to me a lot, because
Yeah.
customers might know what they want, but they won't know how to spec it.
If the OEM, so let's say AFC Holcroft, like you make a furnace and
Right.
Matza make a furnace.
They will know how to spec it.
Right. They'll know the specs of whatever inlet gas they need, whatever pressure and whatever flow. If the customer doesn't know, we can install a flow meter for them.
Okay, installing flow meters.
Yep. We would install a flow meter, maybe have 7 days of data. They would send us back the data logger, then we would look at the max flow during that time period. And actually that's very useful in heat treat, where they don't know their flow. They just know that their nitrogen bulk tank has given them everything they need for the last 5 years. And if we can narrow down their flow for them and size a generator, that's very useful.
And especially for captives, because they might have this huge tank, but for different processes, and they might lose track of the amount of nitrogen that they're using on their heat treat, because they just fill it up every week or every other week. But if they have a variety of application with the usage, you will have to measure the application itself. So you install a totalizer. Great answer, very practical, by the way. So now let's talk about cost. When does it make sense to generate your nitrogen versus having a tank? Because there might be smaller furnaces or there might be huge furnaces. How does that work in the States? Because when I'm in Mexico, usually companies pay a fee for the bottle, a monthly fee. They have a long-term contract with the supplier of the gas, and then they're just paying for the amount of gas that they need, right? And they might have a minimum and a maximum rate. I don't know how those work. So what can you tell us about costs and ROI?
Okay. Typically, the ROI is always very healthy. And we're talking from 40, 50% savings up to 90% savings a month. And here are the reasons why. Number one, the liquid bulk is a gas that's made of liquid and then it's evaporated to a gas again. Okay, so if Praxair are delivering to 5 heat treat facilities in Monterey, then that costs money for that driver to go around and fill up those tanks, first of all. And then each tank is rented from the gas company. You don't own that tank. So it's a never-ending operating expense.
It's a great business model.
Yeah.
Praxair.
Yeah, it's a good business.
It is.
And really, our selling point to the end user is why would you buy it when you can make it? Why would you pay someone else when you can do this yourself? Because the air is all around us and the air's free, and all we're doing is compressing it and separating the oxygen. So typically, if a customer is spending, let's say, $1 per 100 cubic feet of nitrogen, they could make it for 12 cents per 100 cubic feet of nitrogen. So you can do the math on that, where if they're flowing 5,000 100 cubic feet a month, then they could save $3,000-4,000 a week, sometimes 20,000 a month they could save, which is a lot of money.
You're basically saying that the amount of producing against the cost of purchasing it from somebody else is almost half.
Sometimes 80% less.
So it's very significant. So the point is just buy the machine and the machine will pay for itself.
Typically, our best projects are literally less than 1 year ROI.
Okay, that's great ROI. Now, Follow-up question. When does not make sense to
Good
buy a
question.
nitrogen generator?
Okay. If the customer isn't using a lot of nitrogen, or they're using it in an intermittent way, if their usage is sporadic and they maybe only use it 2 hours out of a 12-hour shift and it's not a continuous flow, then that starts to not make sense. And we have that conversation on the front end. One of the things that really helped me is to look at an invoice. And if I can look at an invoice for the month and I see they're only using 5,000 cubic feet in a month, and that doesn't make sense. It won't justify the expense on the front end. So those conversations are easy to have. So it doesn't make sense when the usage isn't high. It doesn't make sense if their costs from the gas company are actually pretty good to begin with, which happens if they've negotiated a good price because they're a multinational company that they've got a really good corporate price, then that's a challenge as well. But a lot of the smaller heat treat facilities, or even some of the bigger ones, you would not believe how much money they're spending on nitrogen monthly, and nobody thinks about it until someone in purchasing says, "Wait a minute, why are we spending $25,000 a month on a utility if we can make it ourselves?"
Mm-hmm. Yeah, I mean that's the bottom line, when people actually notice how cheap it is to produce your own gas against buying it, and the costs associated with it. That's big. If you're talking about that 50 to 80% of margin of producing it against buying it. So, Paul, it's been great talking to you about nitrogen. Very educational. I did learn a lot. That's why I like to also do this kind of podcast, so we can actually show the audience what I do learn myself. Is there anything else you would like to cover on nitrogen generation before going to the next section of the podcast?
Yeah, I think just keeping an open mind and understanding that there's different ways to deliver a certain utility, whether it's oxygen or hydrogen or nitrogen, and I think everyone is looking at cost savings, especially after COVID-19, where people are laid off and business has slowed down. Some of our best projects in the last 6 months have been directly related to the CEO told all of his managers, if you find a cost savings project, we're going to give you X amount of dollars.
Everybody's talking about cost saving and also going green. I mean,
yep.
There's carbon emissions.
There's an economical impact too. When you have a nitrogen generator, there's no longer a diesel truck driving around delivering gas. So there's one less truck off the road.
There you go. That's a great sales pitch. I see that you're in sales now, right? Yeah. So now let's talk heat treat hack, heat treat gadget. Is there a heat treat hack or a heat treat gadget that can be applied to nitrogen that you know or do you use regularly?
Not really. Again, we're like we said at the beginning. I'm not a metallurgist. I'm not a heat treat. We provide a utility that can help in that process. So I rely on the smart guys that we work with. We employ some of the best industrial consultants, some of the best heat treat consultants, and they've got decades and decades of experience. So we rely on them for any of the inside technologies.
I believe that's your hack. I mean, you entered to a new market 7 years ago, and you hire consultants that know their stuff, and they're helping you to be successful in this market. So I believe that's your hack. If you want to enter to a new market or get into something new, hire a guy that knows what we're talking about. Because you just mentioned a bunch of guys like the heat treat doctor, Jim Cini, and you just mentioned a couple of big names. So I believe that's your hack.
Yeah, and the other thing which we've found useful, we have a demo unit at Super Systems in Cincinnati. So Chuck Thomas and Jim.
You're talking to the right guys. I mean, those are like the top of the top heat treat guys.
Yeah, so they have one of our generators at their facility they use for testing. They can test different atmospheres for customers that need it. So that's been a helpful thing. And we we need to do more of that. It's just really expensive to give away a generator for someone to use. But we have rental options. We have a project right now that the customer is going to rent a generator for 2 months to try it. And what they're doing, Carlos, is they want to test at a lower purity to see if the finished parts are the exact same. So we're giving them multiple purities. We can do multiple purities within the same machine. So the customer is going to have it for 8 weeks, and they'll test at different flow rates and different purities with test parts, not a whole batch. But they.
We didn't talk about this. Sorry for interrupting, but how hard or how easy is it to install a generator or move it around? Because you mentioned that you can have a generator rented for you say 2 months, right?
Yeah, 2 months, 6 months.
But I wouldn't do that for a furnace or a generator, a thermal generator, never. So I'm assuming it's relatively easy to install.
Yeah,
the installed the unit.
Yeah, really. If we think about left to right in a linear fashion, an air compressor is an air compressor, and typically most facilities have extra shop air that they can divert to the generator. So that's out of the equation. The generator itself is on a skid. The valving cabinet, the beds are all on, like, say, a 4 feet by 4 feet skid that can be moved with a forklift really easily. And then the buffer tank is a buffer tank. Again, it's not heavy. It might be quite tall, but those are the two components that we would ship, would be the generator and the storage tank. Most times the end user would supply the air to the generator.
Okay, so relatively easy compared to for this installation. Well, Paul, it's been great talking to you. Getting a educational introduction to nitrogen. Thanks for taking the time to share this with the audience, with the Heat Treat Nation. Now, just to finish the podcast, on a more human side, because you just entered a new market 7 years ago that was brand new to your company, and I believe you're being super successful. You have a product that is delivering added value and ROI, especially to the customers. But now let's talk to the new generation of heat treaters. Do you have an advice or personal experience that you would like to share with the new generation of heat treaters, with the younger guys? You just mentioned that you have a bunch of engineers at your company that are working to satisfy the demands needs. Is there something that you would like to say that you learned the hard way through your career?
Yeah, I think, again, without being a heat treater or a metallurgist, I think keep an open mind to different technologies, different ways of doing things. One of the things I've learned about heat treating is a lot of people are stuck in their ways.
Yes.
And when you ask, why are we doing it this way, they say, we've always done it this way. And again, some of our most successful projects have maybe been a younger engineer who's maybe from an engineering background and is more open-minded to looking at different technologies and different ways of doing things. Now, keep in mind, the reason things work is because they work. You don't change everything, but there's always the ability to do things more efficiently, save money for companies. So we like it when we have someone that's open-minded in our projects to investigate how nitrogen generation is a better solution than paying someone else to give it to you.
Thank you so much, Paul. Thanks for being on the show. This was Paul Cairney from South Systems talking about nitrogen generation. I would like to remind you that we have weekly podcast, not daily, weekly podcast. We're on Spotify, LinkedIn, YouTube under the Heat Treat Podcast. Please subscribe. And we'll see you next week with a new episode on the Heat Treat Podcast, experts talking about heat treat specialists. Thanks, Paul, for being on the show.